Thank you for joining me for this Idaho Environmental Forum Shorts. I'm Elli Brown, an Idaho Environmental Forum board member. Today I'm going to give you an insight into Idaho National Laboratory's role in space mission. But first, a couple of housekeeping items. Idaho Environmental Forum is a nonprofit, nonpartisan educational association whose sole mission is to promote serious, cordial, and productive discourse on a broad range of environmental policies affecting Idaho. Just like everyone else, we've temporarily suspended our typical in-person events, but still want to bring you thoughtful conversation about what's up in Idaho's environment. I'd like to thank our sponsors for making these events possible. You can find a list of our sponsors on our website at idahoenvironmentalforum.org. With that, let's talk space. When you think of NASA's space missions, what do you think? The iconic countdown to liftoff? 5, 4, 3, 2, 1. The first pictures of Americans landing on the moon, extraterrestrial life. I'm sure everyone has their own visions, memories, or childhood dreams. Do many people think of the desert west of Idaho Falls? Likely not. From the beginning of space exploration, Idaho has had an important role in supporting NASA missions, which continues today. Starting in the late 1960s, Craters of the Moon in south central Idaho proved to be an invaluable hands-on learning environment for astronauts due to its unique and rugged terrain, as well as providing valuable scientific insight. More recently, Idaho National Laboratory, based in Idaho Falls, plays a critical role in supporting the power supply for NASA space missions. INL's expertise in supporting NASA missions stems from their world-class expertise and facilities for nuclear energy. Space missions for over 50 years have been fueled by radioisotope thermoelectric generators, or RTGs, or similar systems which have safely supported 24 U.S. missions to explore our moon, most of the planets in the solar system, and beyond. RTGs are fueled with plutonium-238, which give off steady supply of heat as the material decays. No moving parts are required. Thermocouples are used to create an electric voltage from the temperature difference between the hot interior and the cold exterior in deep space or the planet's surface. The power supply created by an RTG is steady, reliable, and lasts for literally decades. RTGs provide the power to operate spacecrafts or rover systems such as scientific instruments, robotic arms, computers, radios, drive systems. This also allows rovers to send data and even pictures back to Earth, such as the rover selfie by Mars Curiosity rover. Using plutonium-238 as a fuel source is where INL leverages its experience and expertise in handling and testing radioisotope materials. INL personnel complete the RTG fuel assembly. Fuel clads are placed into graphite components to create the general purpose heat source. Then modules are placed into a converter that houses the thermocouples. Following the assembly, a series of acceptance testing is completed to simulate mission conditions. After successful completion of the acceptance testing, the RTG is transported to the Kennedy Space Center. INL personnel provide ground operations support involving the RTG at Kennedy Space Center and Cape Canaveral Air Force Station until after launch. INL personnel are currently in Florida after recently delivering the most current form of an RTG, the multi-mission radioisotope thermoelectric generator, or an MMRTGs, for the Mars 2020 mission, which is expected to launch in July of 2020. The INL team has provided the support for space missions since 2015, starting with the Pluto New Horizons mission, Mars Curiosity, and now Mars 2020 mission, Perseverance rover. Talk about a fitting name for the current global circumstances. The Perseverance mission is part of an ongoing exploration on Mars and will have 4 main goals. First, searching for past environments capable of supporting microbial life. Second, seeking signs of past microbial life in those environments. Third, collecting core rock and soil samples to store them on Martian surface. And finally, testing oxygen production from the Martian atmosphere. You can follow along and learn more about the Perseverance mission at mars.nasa.gov. While this hot topic might seem far out, Idaho continues to have strong ties to NASA space missions with a global impact, and that's something to be proud of. So with that, thank you for tuning in to this Idaho Environmental Forum Shorts. If you'd like to hear more of these, please send us an email with your topic idea. The email address is ief@idahoenvironmentalforum.org. Please join me again in thanking our sponsors for this event, and we'll chat again soon.